welcome to this STEM webinar on digitalisation in infrastructure. My name is Liz Varga. I'm going to present a talk to you today about the bigger picture of digitalisation. I hope you find it interesting and that it'll spark some questions in your mind about how we act into our infrastructure systems. Okay, so I just want to start my timer, which is now going. Okay, so the first question is, what do we mean by digitalisation, of course? So digitalisation is merely the conversion of any form of information into a series of zeros and ones, into sort of binary representation. Now, what that does is enable automated processing of information. So this is really important because it speeds up the transfer of information, but also speeds up the ability to gain insight into large quantities of information. And of course, we can convert all types of information from multiple formats into binary format. So that's digitalisation. So the question then is, what do I mean by infrastructure? Okay, so infrastructure has a much more complicated answer. So I'm using the definition from a document that we helped to, we wrote the technical parts of the Principles for Resilient Infrastructure that's published by United Nations Office for Disaster Risk Reduction. And what we call infrastructure is a set of complex interdependent systems. Now, these are made up of not just physical systems like networks, buildings and assets, but also governance structures, regulatory frameworks, the management processes that we have to operate, the 6 economic infrastructures in particular, which are our energy systems, our transport, water, wastewater, waste and digital telecommunications. Now, we also worry when we talk about infrastructure about interdependencies, whether it's within each of these systems, whether it's between the systems, or whether it's between the systems and the environment. So there are plenty of interdependencies that are in operation continuously in these systems. We also care about the what we might call information systems and technologies that are evident within infrastructure, also the skills to operate the technologies and also the infrastructure, the systems themselves, and then the resources that the natural environment provides, not just to build the infrastructures, but also to provide the services that are delivered through infrastructure. So you can see this one was a much more complicated answer because we embrace quite a lot when we talk about infrastructure. Okay, so what can we say about digitalisation in infrastructure? Well, this World Economic Forum piece of work that was produced called Infrastructure 4.0 was actually highlighting the fact that infrastructure is behind the curve on the adoption of digital technologies. It was a global team that was looking at what opportunities there were from Industry 4.0. Now, these are a set of technologies that many industries are familiar with. And we see industries like manufacturing especially have adopted in Industry 4.0 technologies and have seen much faster benefits in those industries than others. So the situation we're at is that we're behind the curve in infrastructure. So there's more to do than we've done already. Now, one thing that I highlight in this report from World Economic Forum is that the way to make sure that we create platforms that are for human and natural flourishing, meaning that we want society to benefit from infrastructure systems and we don't want to damage the natural environment as a result of using digital platforms. Now, the way to avoid that is to use emerging technologies when we actually create infrastructure itself. So when we develop and devise infrastructure, we should try to embed ways of collecting digital information, of processing information, of using information in a much more responsive and right time way. Excuse me. So the idea here is that we want to we want to think about what we do from outset for the whole lifetime of infrastructure. Now, that doesn't mean we have to forget about adapting existing infrastructures, and that is another challenge. But if we can do it at outset for any new infrastructures, that would help greatly. In this report from World Economic Forum, there's lots and lots of recommendations, and I just want to point out the two here that have got the sort of dartboard picture on in the blue, and they're the ones titled Encourage and Develop. Now, so these two areas are about making sure that asset owners and operators have enterprise digital strategies, so that it's something explicit that infrastructure firms are considering, and they can see how these how the process of digitalization can aid their companies. And then more generally, I mean, encourages the development of a digital commons and marketplaces. Now, this is where data about infrastructure can be shared, and insight can be gained through the performance of infrastructures in different places, of different ages, of different types of service provision. So how can we create a method by which to collaborate? Now, this work is also from the Infrastructure Projects Authority, and it's talking about a roadmap for transforming infrastructure performance. Now, they have this flagship program, which is about leading system change in the built environment. And the roadmap itself makes the really important point of that we must prioritize societal outcomes. So we want society to benefit from infrastructure, and using modern digital approaches are part of that solution. And we need that to achieve improved delivery models. So there's a digital by default infrastructure delivery principle inside this transforming infrastructure performance roadmap. So it's assumed that digital will be there. Now, of course, it's great that we can digitalize, but actually digitalization is maybe just the first step. The being able to digitalize is an enabler, but actually we want data to be shared. Now, how do we share data? Well, if we can digitalize data, that's great. We've got the data in a digital format, but we need cooperation. And often we see a reluctance and maybe a variation in the pace of sharing. Some companies are much more keen to share quickly, others are much slower to share. Now, even if we have got a mechanism for data sharing, and this could be use case oriented. So, for example, for looking at the condition of particular assets and sharing that with other infrastructure organizations who might be affected if those assets, for example, are at greater risk of failure. So even when we have sharing, the people that do share are not forced to coordinate. Sometimes they have to be nudged to coordinate or encouraged, excuse me, by different players perhaps in government or in society themselves, because society can often see that they're not getting a full story about their decision making on which infrastructures to use if they have discretion. Now, data is essential so that we can develop a better understanding and try to automate processes across the whole system. So it's we need more data to be able to get better insight. And of course, the data needs to be continually refreshed. So we can't be reliant on data that's 7, 8, 10 years old and still using that same data analysis to make decisions for today, because our environment changes all the time. Fragmentation in infrastructure is often quoted as the key reason for this lack of cooperation. And what that means is that the sectors have grown up, even the subsectors and different modes, for example, in transport infrastructure, they've matured in different ways and have different legacies. And so some of the systems they use, some of the processes they use aren't industry-wide. And therefore, it's difficult to cooperate because they are fragmented through their legacy. So it requires a shift towards cooperation. Now we can enable through this new layer. So if we create this, this digital layer on top of physical assets, we can call it the data layer. And if we have that data layer, what we have is a copy of the physical assets in our computer systems. We say in silico because it's in the silicon chips, if you like. Now, once we have that replication, so we have an idea of the properties of the different assets, of the materials and the flows going across all those assets, we can be looking at that system in that data layer. So it becomes a multi-organization view of how the whole system is working end to end. So we can track supply chains all the way through to generation, all the way through to distribution, and then even through to the use of infrastructure services. So once we get these more modern day descriptions of digital twins, because they have this monitoring data of the condition of everything, the flows of everything, if we have these digital twins, we can see the interaction between everyone in the ecosystem. So as an infrastructure manager, I could see what other infrastructure managers are doing. I can see what other transport service providers are doing, what customers are demanding. So I get a much better view of how the whole system is working. Now, of course, that means that we can coordinate these really quite complex ecosystems. And complex, I mean that they're co-evolving, they're dynamic, they have emergent properties, and they're non-linear. So we have these really complex systems, and we can coordinate better at the data layer because it's less risky than trying to coordinate at a physical layer, where we have the chances of making a change in a physical system that can go wrong. So these sophisticated digital twins can help this coordination function. So we no longer need the infrastructure operators to try and coordinate so heavily, because the data layer provides that ability for automated decision making to coordinate across the different systems. Now, the more complex, of course, and the more fragmented the ecosystem is, the better the gains we're likely to have by having this digital layer. So already we can see that there's like a network effect from having digitalization. And this is what my presentation is about, really, is to think about the bigger picture of what does it mean if an organization digitalizes and then joins up with other organizations that can also digitalize. So let's come back a little bit to Industry 4.0 and have a look at some of the enabling technologies. So we have things like the Internet of Things, or sometimes called cyber physical system. So this is this idea of assets having collecting data about themselves, about the flows going through them, about the environment near them. So this could be the condition of, say, weather, the condition of temperature, and so on. Now, of course, it's all well and good collecting data, but you need big data analytics. And there are terabytes of data being collected on systems, sometimes called smart systems, and terabytes being collected, hourly. So the scale of data is far more than humans could analyze themselves anyway. Of course, cloud computing is an enabler within Industry 4.0 because it means that data can be stored in places that are away from the physical systems and don't have to be managed by the infrastructure operator. It's a provided service, and so on. So we've got lots of systems, but in order to get to the outcomes that we want for society and for the environment, which are better economies, better safety, protection of the environment, we have to mediate this through a whole system of process integrations. And this is about trying to join up how these Industry 4.0 technologies achieve these outcomes, and is integration with the human in the loop. So how does the human enable these digital systems to deliver the outcomes that we want? So this is about getting to the outcomes that are not just for the organization in terms of efficiency, but also for the bigger picture, because critical services are a societal enabler. We might also think about the different categories of digitalization. So, for example, there'll be specific tools that enable Industry 4.0 technologies like building information modeling, particularly in infrastructure construction, maybe virtual reality, so that we can experiment in, or step into future environments and actually see how they would work before we can even start considering construction. And then we also have the digital systems that might be in the operational environment, so sensors, the use of 5G, of edge computing, and even blockchain for transactions across different providers. And then we can even think of digital infrastructure as an asset in its own right. So we can codify the systems through the creation of digital twins. We can represent the data digitally, the data structure digitally, so ontologies and data schemas. These are all digital assets, and there's an industry out there that actually has been emerging over decades that do this and are doing it really, really well. So there's there are sort of industry making through also digitalization. Now, of course, if we worry about the infrastructure operator, they will digitalize because they want to increase the efficiency of their assets, so they can get more services provided through their infrastructure systems. They want to reduce the cost of maintenance, and they want to optimize their load. But actually, they also have other benefits about avoiding sending people into extreme or remote or even dangerous sites, because if they're monitoring that through digital mechanisms, then only the absolutely essential sort of human presence needs to be implemented. And of course, with digital information, we can make decisions at the right time. And so this is the getting the right timescale for decision making. Okay, now the network effects, of course, are great. Because it means once we can coordinate better, we can reduce the price for the people using the system. But this has an unintended consequences in the fact that actually, if the price is cheaper, then other people will also use the system. And of course, as the price gets cheaper, we see demand rising. So these are sort of fundamental laws of economics. Now, once we have a price that is so low that it attracts too many people, we'll get congestion in our infrastructure systems. And this is not a desirable property. We want the load factor to be as close to 1 as possible, which means we want the optimal amount of utilization of our infrastructures. And this is why coordination is so important, because we can divert the demand for services to other parts of the infrastructure that can also provide those services, if it's possible. Okay, infrastructure, just like every other system, has to meet sustainable development goals, and these 3 are the ones that are really important for infrastructure systems themselves. So it's about making sure that we build resilient infrastructures that are inclusive. So you can see multiple outcomes arising from infrastructure, and digitalization has an opportunity to contribute to that. We have responsible consumption and production. So we have to make sure that we're using resources that are sustainable. So often it means using renewables. And also to take climate action, because we don't want infrastructure to contribute to climate change, but also infrastructure has to deal with the condition of the climate. So there are two aspects to climate change for infrastructure. So these meeting the climate challenges have been investigated, and digitalization can respond in different ways to mitigating against preventable, avoidable failures, but also stopping cascading failures through the interconnections we have in infrastructure. We also have digitalization providing the means to improve planning and the delivery of infrastructure solutions that are much more cognizant of the local hazards that are existing. So therefore, digitalization provides the means to make better decisions and avoid creating vulnerabilities. Now, of course, sustainability is a brilliant outcome of infrastructure because it means that we can measure the amount of use of materials, the amount of waste we create, how much energy we are using, how much energy we can recover from our infrastructure systems, because often infrastructure generates outputs like heat and waste that can be reused. It can also provide means for supporting decision making that means that we use less resources and are less impactful on the environment. So we can avoid the use of virgin natural resources, and we can also just make better decisions about the emissions and unintended or undesirable outputs of our infrastructures. So digitalization helps with sustainability. And of course, it also helps with the economy because it means that we can, as the role of the government, it can help to plan projects better, to make sure that we have better information for better decision making, so that we can avoid unexpected rises in prices, for example, or unexpected risks and so on. Operationally, to reduce costs, of course. For the industry, it means that there's more competitiveness because there's a better understanding of how to do things better. We also have more export capability and capacity, because it means that we would be recognized as much more highly mature in the construction and operating environment of the industry. And of course, for the users of infrastructure, it means that we've got better understanding of the services that we can get from infrastructure. There are several ways to measure social and economic impacts. I would just recommend to look at this report. I won't go through these right now. Again, these are social benefit measures, quality of life and access to basic services. The issue with many measures is how to know the contribution of digitalization to these outcomes, because it's not just digitalization that creates the outcomes, but we know it contributes in a strong way. Okay, of course, industry benefits are also really important, and it's about reducing cost, but it's also about increasing that reputation of industry to so that people believe that they better know how their systems are working, they address faults more quickly, and they also use their capacity in much more smart ways. But of course, digitalization itself has its own cost. And it also creates unintended consequences. And I've sort of touched on one or two, but I just want to probe these a little bit more. Now, of course, we have project costs for digitalization. We know that there are many failures in projects, and we continually try to improve how project performance is. We know that systems cannot be fully automated. We need human decision makers in the loop. So we have to create manual overrides for them. Privacy and security are often emerging problems because we deal with one layer of privacy and security, and then another layer manifests itself as a risk or something that's not fair to all users of the critical infrastructure. So there's also the risk that if we embed the same digital methods into all our infrastructures, if we had a common source failure, all of our infrastructures could fail. And this is particularly true of software viruses or phishing attacks. This is an interesting paper that talks about how we might digitalize in a responsible way compared to a selfish way. So how do we digitalize that encourages more shared transport, more use of public transport, rather than in a more sort of individualistic way of using infrastructure? And these are just some really nice examples from the industry. There's also risk to jobs. Some jobs are more likely to be automated. So the telemarketer or the court clerk or the dishwasher, these jobs can be now done with machinery and with digital methods. The creative industry jobs, the ability for individual skills like the surgeon skills, public relations, are unlikely to be digitalized. But even here we're seeing digitalization taking over some of their tasks. So it has got an impact on employment and the types of jobs that our society has available. And of course, when we digitalize, everything is heterogeneous, which means that it's not all the same. We've got different types of data, we've got different formats that are collected. And so to integrate across all these pieces is not a simple challenge. So the whole system needs to be looked at in the round. We also, of course, want to worry about the consequences of running digital systems. And this Chris Skidmore review that's just recently been published on Mission Zero, which is about how do we get to net zero in a sustainable way. But digitalization is a key component of that, but has got unintended consequences. We know there's a carbon footprint and a growing carbon footprint from digital mechanisms. And this is the amount of computer processing power that we have and the need for cooling and air conditioning of our cloud computing, of our server farms. We also have the risk of rebound effects on the climate, because the more we create digital technologies and computer centers, they are creating an undesirable effect on climate change. We are making climate warmer. And of course, that means that we're also having to consume more energy now to cool our systems. And therefore, we're in a positive feedback loop, making it continually worse. So, and of course, we don't know how, we cannot quantify exactly what this risk will be. And therefore, there's uncertainty about it, which is a real concern. Therefore, we need to be worrying about how we can reduce the environmental footprint of digitalization technologies. We also tend to absorb privacy and security as sort of, yes, these are things that we have to do. We sort of accept the downsides. We know that there are risks in digitalizing systems. Maybe we do that because we can't quantify the risks. Perhaps we overlook them because we think that they're not significant enough. In any case, we know that there are rebound effects that arise as a consequence of digitalization. And these can be broadly classified into these 5 groups. So we have direct rebound effects. So we had one I described already. When we reduce the price, we make the system more efficient, and then we end up with more consumption, and therefore we actually end up having more demand than we started with, because of the reduced price. Jevons paradox is a more generic description for this, but when it's the same as a direct rebound, but actually there's just more steps in the whole system process. Indirect effects are also common. It means, for example, if we do make something cheaper, it means that people have got income to spend on other things. And do they spend it on other things that are really not desirable for society? There's also a time rebound that economists have talked about, because once we save time, for example, by having a faster journey, then what do people do in that saved time? So it's an opportunity cost. And then, of course, we have macroeconomic outcomes, and this is about boosting total factor productivity, which means that we get better productivity from all of our socio-technical systems. Now, in almost my last slide, we also want to worry about the rhetoric of digitalization. And as you heard from my first few slides, there are lots of good outcomes from digitalization, but what is the reality of it? So, for example, the role of the digital platform is often described as one that facilitates, because obviously the digital platform and the data layer is great for coordination, but actually it's the reality that it's mediating between different parties and organizations, that now that they sort of are forced to or can see the benefits of sharing, they now need to accommodate each other. So it's more of a mediation rather than facilitation role. And one I want to just look at the bottom, there's this transparency and choice. So we might talk about, we can know more things more clearly through the digital layer. But actually, is it that we are creating some greater opacity in some parts of the digital layer, because we don't necessarily probe all the dependencies between different aspects of the system? So we might think we know more, but actually what it will expose is the extent to what we don't know. So actually, there's a lot desirable about finding out things we don't know, but it does make us worry about what we're not addressing and not attending. Okay, That's my seminar over. I just want to say that digitalisation is a core component of a new MSc that I'm running at the Civil Environmental Geomatic Engineering Department at UCL. It's infrastructure systems. It's one of the 4 components. We also look at sustainability, at resilience, and also at public policy. And we treat infrastructure system as a co-evolving system. It's not static. We see it as a dynamic system that's being eroded and used all the time. And it's about working on industry challenges and making sure that we do some innovative work on infrastructure by understanding how the whole system is operating. How can we do this and have better outcomes? So please do have a look at the advertising on UCL for this. Okay, so let me stop sharing. And just to say thank you all very much for coming to listen to the lecture, and I'll hopefully see you soon in the future. Goodbye for now.